Hey there, everyone. This is Udadita from Tech Sparking, bringing another session covering data engineering question and answers. And in today's session, we're going to see how to submit a Spark job in Cluster. So today's session is mostly going to be practical, where I will walk you through a Spark code and then I will submit the same job in a local cluster. So as usual, I'm going to start off with a brief introduction of myself. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines in on-premise as well as on clouds for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. So before going over the Spark code and submitting the same job, I would just like you to highlight some of the stuff regarding submitting a Spark job. That is, so there are two ways we can submit a Spark job. The most widely used and the popular one is the cluster mode. The other one is known as the client mode. Okay, so in real world projects, jobs are mainly run in cluster mode, and I will tell you why. So, what is the difference between the client mode and the cluster mode? The only difference is when you submit a Spark job in a client mode, it means your Spark job or your driver program will be running on the edge node, the node where you log in. Okay, so what is edge node basically? So you'll be given a putty, right? You'll be given some kind of a host box or some Unix box where you'll log in and then your node will come up, your cluster will come up. So over there, when you try to do any HDFS LS or anything, you try to run any Hive query. So that's the edge node where you are basically, sitting there as a client and running everything. But if I talk about cluster node, so the concept of Apache Spark or Hadoop or Hive, eventually they are running in a distributed ecosystem, right? So it's not only one node where you're setting it. So they are different other nodes or different other systems which are interconnected with each other. Okay, so it may so happen that the node where you're sitting in or where you're trying to access everything, that's just one of the cluster node. So that's just one node of the cluster, and you may want your Spark driver program to not run in that node but into some other node. Okay, the reason being, suppose there are 5 users and all 5 of them running in the client mode. So all of them are going to be accessing the same edge node, right? They're going to be accessing from the same system where not system actually, it's a virtual node or it's a remote host where they will be logging in and try to access all the tools, so that is Hadoop, Hive, Spark, and everything. So what happens if all the 5 users submit the Spark jobs in client mode at the same time? Then the edge node will be heavily congested. So all of the driver programs will be running into one single node. So this will create some congestion. This will take a toll on each and every Spark job, right? So that is something which is not recommended. Whereas if you run the jobs as cluster mode, in that case, what happens is there are 10 different nodes and you have 5 users. So it may so happen that all the 5 different driver programs will be running in different 5 nodes, not at one single node. That is the edge node. Okay, so that's the main reason why running the job in cluster modes in the real world projects is highly recommended. I mean, that's how it is eventually carried out in almost all the projects. But in today's session, in today's example, I will be running in client mode because I'm just showing this from my local machine and there is no cluster setup. So obviously will have to run the job in the client mode. There's not much of a difference. The only difference is when you will be using the cluster mode. In that case, the logs will eventually come upon in this Yarn history server or Spark history server. But whenever you're running in the client mode, by default it is client mode. If you don't put the deploy mode at cluster as cluster, in that case what happens, the logs will eventually, whatever the print statement, whatever the show statement that you have put in your code, that will come up into the same node where you are running. Okay, so when I'll be running the job, you will see what I'm trying to explain, and you will get an idea of it. So before running the Spark job, let me just walk you through the Spark code that I'm using. Okay, let me just tone it down a bit. Okay. Hope everyone can see my screen and the code. So this is one basic Spark program where I'm reading a CSV file and just doing some aggregation, a grouping operation. So let me just walk you through the code first. So first of all, I'm just importing all the Spark SQL libraries, the Spice Spark SQL libraries. So Spark session is something that I definitely need because that's the entry point of a driver program on the Spark job. Okay, so without the Spark session, I simply cannot read a file. I simply cannot run any Spark job at all. I mean, the code itself won't be recognized as a Spark job if I don't use the Spark session. So with the RDDs, we were using the Spark context, if you remember the previous sessions. But this is the Spark 2.0. This is the later version of Spark, which gives me the data frame API, which is strong because of the catalyst optimizers and whatnot. So use that framework to use to get the most of it. So I'm going to be using Spark Session. So Spark Session is the entry point for each and every Spark job. You have to create the Spark Session, and then so the statement goes something like the Spark Session, and then the builder. Then you have to provide an app name. So it can be arbitrary, it can be anything. So provide over here, I'm just giving here friends by age, but you can put anything like ABC or XYZ. It doesn't matter much. Okay, then will be the actual statement which will kind of like create the Spark session. That is the get or create. So this is something which is very usual or very generic for all the Spark code. You have to use this statement to create the Spark session and then assign it to variable like Spark or anything else. So over here, there's another thing which you can put is the master. Where do you want your Spark session to run? So usually when you'll be using the Hadoop cluster, your jobs need to run on the yarn. I mean, not necessarily on the yarn, you can also run it in the local setup as well. So how do we put it is that simply we can write master, and over here we can just say yarn. Okay, so this will make the Spark job run in yarn. If you don't have a yarn setup, you want to run over here in the local, you can just use local and use all the cores. I mean, star means how many CPU cores you have in your system. It will use all the cores for the parallelization. Okay, but if you don't want, say, you have 4 cores in your machine, or say 6 cores, and you only want to use 2 out of them, you can put something like local and then 2. But over here, I won't be running the job in local mode. I will be running in the Hadoop cluster. It's like a pseudo Hadoop cluster, just a one node machine. But even though with that, I'm going to be running it in the client mode. Okay. So this is the first step, that I'll be creating a Spark session. Then the Spark session that I create, it's in the variable Spark, right? So using this Spark, just setting up some log level, but even though this is absolutely optional, I mean, if you want, you cannot, if you want, you can simply avoid it. It's not actually mandatory. So for the moment, I just kept it, but probably if I'm not going to be using, let me just, get rid of it. Okay, so I'm not getting rid of it. The reason being, there is another significance is that I'm setting the log level as error. So if I just simply remove it, in that case, all the warnings and everything will come up. But I want only if the errors are there, then I want those to be showcased. I don't want the warnings or anything. But even with that, let me just get rid of it. Okay. So then after that, I'm going to be creating a data frame by reading one file that I'll be inputting, that I'll be feeding into my Spark program. So in the Spark job, I can provide as many arguments as I can. So over here, I'll be putting one argument. So sys.argv is actually the list of arguments that you can pass into not only Spark job but any Python code. Sys.argv is part of the Python code. So one means there would be the first argument that will be input path. If I put 2 here, in that case, the second argument would be the input path. Okay. So over here, I'm just putting one argument. So that's why it is 1. And if you put 0, it will simply show the script name. So that's how it is. So input file, I'm passing in as an argument in the script. Then I'm going to be reading the CSV file from that path and create a data frame out of it. So to create a data frame, then again I have to use the read API, that is simply the read keyword from the Spark session, or the variable that I created using the Spark session, right? So the statement goes something like spark.read. Then the option is I want the headers to be highlighted. Okay, if it's a CSV file, obviously there's an optional comment that whether the first row is a header or not. If I put header equals to true, then it will recognize the first row as the header. If I don't, then in that case it will recognize the first row as a row itself. So it will kind of jeopardize my schema. I don't want that. So that's why I'm putting header is true. Then there is the option of inferring the schema. Inferring the schema means is that it will try to scan the columns in the file, and it will automatically put a schema based upon the data that is present. So if there is a numeric data, in that case, it will infer the schema as integer. If there is a if there is some characters or text, in that case, it will infer it as a string. Okay, so that's the significance of using infer schema. Then I have to put the CSV, and it will be wrapped in with the path name that I'm providing as an argument. So CSV, why? Because I'm reading CSV format. Okay, if I suppose if there was a Parquet format, in that case I would be putting Parquet instead of CSV. So I think I have shown this uh, how to read a file, different files from using the Spark session in Databricks in one of the early session. So this is just the same thing over here. Now, since I have read the data frame, what I'm trying to do, I want to showcase the count in the data frame. I mean, how many rows are there? Okay, so that's why I'm calling the count method on the data frame. Then what I'm doing some aggregation over here. So there are uh, four different columns as far as I remember. There would be the serial number, name, age, and the number of friends. Number of friends means each and every person, how many number of friends does he or she have. Okay, so these are the columns that I mean, those are present in the file. So I'm just grouping by the age and then aggregating the number of friends to get an average. Okay, so if you remember in SQL queries, how do we write and uh, group by statement, right? It's something like group by age or group by something. Then I do select average or select count, something like that. Okay, so it's the same thing. Over here, I'm putting the AGG function, which comes from the Spark SQL functions library. And then using the AGG function, I am averaging, grouping by the age, and for each and every age or for each and every person, I am just trying to for each and every age, I'm just trying to find the average number of friends that age group has. Okay, so suppose like there are three person having the same age and they have different number of friends. Okay, so if I want to get for that particular age what is the average number of friends, what will I do? I will simply add the three number of friends column values and then divide it by 3. So this will do the same thing. And I'm using the round function because it may come up as a floating point, so it may have a lot of numeric or digits after the decimal value. I just want to round it up to 2. And then there's the alias. Alias means whatever the average value that will come up, so it will have the column name as friends average. Okay, so that's how it is. So my data frame should look like there's the age column and there's the friends of average. So for example, for the age group 30, in that case it has the average number of friends, say 100. Okay, there's just one simple example how the data frame would look like. And then what I'm doing is just I am ordering by the data frame by the friends average, that is the newer column which I just created, by taking the average of each and every age group, and then I'm ordering by descending in order, so that the order would be in descending and only showcasing first 10. Meaning, if there are say different age groups having different number of friends, in that case the ones which have the higher number of friends, the first top 10 rows will be shown. Okay, so if there's like 30, then 30 number of friends, average number of friends is 100, then 31 average number of friends is 200, and so on. And in that case, if like from 30 to 40 it's like 1000, 2000, 30,000, and at last 1 lakh. In that case, if I just use the order by descending based upon the friends average or the average number of friends count, in that case it will show the 10,000 at the or the 1 lakh at the top, and then 90,000, then 80,000, and so on. It will show up the first 10 records. Okay, so this is what the code is doing. So I have already saved my code into my local cluster. So let me check if all the daemons are running. The node manager, secondary node manager, data node name nodes, the Hadoop is running. Resource manager is also running. The node manager part of the yarn is also running. Okay, so I have all the daemons running, and my script is present over here as. So this is the script that I'm going to be using. Okay, and to run the script, so to submit any Spark job, I have to use this keyword Spark submit. Then this script name. That's it. This is the bare minimum that I have to write. But that's not all. I mean, there are several other arguments or several other configuration settings that I can put. those are optionals, but this is the bare minimum that you have to put. You have to put the Spark submit command in order to make the Spark understand that you're going to submit a Spark job. Okay, and then followed by the script name. So this script has my Spark code, right? So now if you look at the code, I'm feeding the input path as an argument. Okay, but over here I haven't put any argument. So let me put that argument over here. So this is on HDFS. So before running this, let me just check if the path is present in my Hadoop cluster. So HDFS, TFS, LS, inside Uday, I believe it is CSP data. Yeah, so this is the file I'm trying to read. So you can just put the path or you can put the specific file path, I mean, along with the file name. I mean, it doesn't matter because what happens when you just put the path name, it will read all the CSV files inside this Uday CSV data. Right, but if you want to say there are like 10 files and you only want one file to read, in that case, you have to put the specific file name. So let me just put the specific file name. It would be easier for you to understand, but let me have a look at the data, how it looks. So to browse any file, I will use the cat command. And I just want to look at the first 5 records. Okay, just to take a look of the data, how it looks. Right, so there it is my CSV data. So one is the serial number, name, then age, number of friends, right? So I'm gonna be first take the count, and then based on this age group, that is 33, 26, based on this age group, I'm gonna be calculating the average of the number of friends. That is the fourth column, 385, 291, and so on. Okay, so my file is present in the Hadoop path. I'm gonna be using the same file for my Spark submit job, and I will feed it as the input path. Again, okay, I just forgot the script name. Sorry. Again, I have to copy the script name. Average friends counts.py. And then I have to Spark submit the script name, and the path was /uday /csv data. And I want, there's only one file inside it, and I want that file to be read by the Spark job. Okay, so this will simply run my job, and it will run my job into my local mode, I mean, as a local mode, and then it will showcase whatever the statements of it, I mean, the show statement and whatever the count statement that I put over here. But if I want to run in the master yarn, I mean, in the yarn cluster, in that case, I have to put one more keyword, that is the master yarn. So this will make sure that my Spark job runs in the yarn and not on local. Okay, since I have my yarn node up and running, so this is the yarn UI, this is how it looks. So currently I haven't submitted any application, so and I'm using only one node, because this, as I told you, right, this is just a single machine, it's not a real world node, but I have like one v core being used, and this is the minimal allocation, and total up to 4 I can use, and the memory is around 8 GB that it's gonna be eating. Okay, so this is the yarn UI, and this is the node structure that I have, very minimal, just to show you how how the Hadoop applications or how the yarn applications look like in the real world. So obviously you will see the vehicles are much higher, there would be like 100 nodes and so many amount of memories, but over here is just a local node setup. Okay, so now this is the Spark submit command that will be used to run my Spark job, and it is complete, even though there are several other arguments or configurations I can provide, but not on this session. I will show you all this in some later session in the when I'll be covering the memory usage and everything. So let me just run it, and all I have to do is just press enter, and my Spark job will commence. So all this info and everything, this will come on, no need to worry about it. So you can see there's an application ID generated, right? So this is the yarn application ID that's generated, and the job is now is getting started. No need to take care of all these infos that are coming in the logs. These are just arbitrary things. So you can see now the data frame count is being shown is 301. So total 301 records are there. And if I try to explain this data frame, so this is the show command that I put, right? For each and every age group, what is the friends average? And I am showing this based upon the descending order value of the friends average. I mean, each and every friends group who has the highest number of average friends, so those are being shown at the top. So average 18 from this data, average 18 age group of 18 has the most number of average friends, that is the 448. Okay, then comes the age group of 56, which has 399, 63, and so on. So only top 10 rows are showing according to my Spark code, which I am doing over here. All right, so this is basically how you can submit a Spark job in the cluster. Now, if I turn to my Yarn UI application, I just refresh the page, and you can see this application ID is generated, right? So this is how the Yarn UI looks, and in the real world project as well, you will see the same UI is the same thing. The only difference would be from here the logs will be generated in the log session. Now it won't show anything because it's simply it's not a actual cluster setup. Okay, and neither have I run in the cluster mode. So that is why it won't show up anything. But in the real world project, if you click on the logs, you will see everything, the standard out, standard error, and everything. And if you just and the way you're saying is that you won't be seeing these things into the console in the project if they are using the cluster mode. In that case, you won't be seeing the data frame count over here nor this data frame. You just have to click on the logs from here, and then you can see all these results. So that's the only difference between the cluster mode and the client mode. This job has been run in the client mode for the moment. All right, so this is all about how we can submit a Spark job in a cluster based upon different modes, that is the cluster and the client mode. And overall, there are other several configurations that we can put in the Spark submit command that I will cover in one of the later sessions. So for the moment, that's all from this session. If you need any clarification, if you have any doubts regarding Spark setup in the local Hadoop, Hive, all these things into WSL, that is a Linux environment, just do reach out to us. We cover almost all the necessary tools in our data engineering course, such as the Spark, Hadoop, Hive, as well as AWS with hands-on coding and real-world project. So in case of any queries, just give us a call and we will be happy to help you. Thank you, everyone.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.